All right, so let's talk a little bit more about abbreviated electron configurations and do a little practice with it. Okay, so get out your periodic table and you're going to find the elements and try to figure out what their full electron configuration would be and then what their abbreviated electron configuration would be. Remember, full electron configuration will be the entire string of orbitals that show the number of electrons. Abbreviated electron configuration will go to the noble gas, the last element, and the row above it, and then everything on the row that that element is on. A couple of rules for abbreviations is you can only abbreviate from the last noble gas. Don't go to an element before it in the same row, only abbreviate from that last noble gas. Okay, so let's take a look at argon. So this is the full electron configuration of argon, but what's its abbreviated electron configuration? So you want to find the last element in the row before it. So the white section shows the full electron configuration for neon, so that represents neon. So we put the neon in the brackets, and then you only put what's in that row. In this case, it would be neon 3s2 3p6. All right, how about calcium? Here is the full electron configuration of calcium. What's its abbreviated electron configuration? So as you look on the white represents the element in the row before it, which is argon. So we're going to put argon in brackets. And it would be argon, 4s2. The only electrons, those valence electrons that we're focused on, are the 4s2, 2 electrons in the 4th s orbital. All right, how about scandium? Did you get it? Scandium is the 3rd element over on the 4th row. So it's argon, 4s2. Now remember, the d orbitals are always one number less than the row it's in. So it's not 4d, it's 3d. The reason is that those d orbitals are actually buried underneath the 4s. So it's 4s2, 3d1. How many valence electrons does it have? When you look at valence electrons, you're going to be focused on how many electrons are available in that outermost row. So in this case, scandium has 3 valence electrons. 2 in the 4s, 1 in the 3d. All right, so let's try antimony. So antimony's symbol is Sb, so see if you can find that on the periodic table. As you go scanning around, you will notice that I'm going to look back at mine and see that it is number 51 on the periodic table. So this is its full, or its abbreviated electron configuration. It's krypton, that's the element before it, the noble gas in the row before it. Krypton, 5s2, it's in the 5th row. 4d10, remember that the d orbital is always one number less than the s orbital. And then it's the 3rd one over on the p, so it's 5p3. All right, how many valence electrons does it have? Now I told you that the valence electrons are only the electrons in the outermost shell. The key with the d and whether we're going to count the d electrons as valence electrons is the d full or not? If the d does not have 10 in it, if it's any number less than 10, then we say that those are valence electrons available for chemical bonding. But if the d is full, then the whole 4th shell is full. The s, the d, and the p are all full, and they are not available anymore. So if you go beyond the d and it's totally full, we don't count them as valence electrons. So in this case, we would say that there are 5 valence electrons. 2 in the 5s, 3 in the 5p, that equals 5. All right, how about the electron configuration of rubidium, Rb? Go to the noble gas before it. That would be krypton, and it's the 1st one in the 5th row of the s block, so it's 5s1. All right, how about cesium, Cs? Well, the noble gas before it is xenon, so we would say it's xenon 6s1 because it's the first one in the 6th row in the S block. All right, how about gallium? The noble gas before it is argon, then it's 4th row, 4s2, 3d10 because the D is one number less than the row it's in, and it's the first one in the P block in the 4th row, 4p1. Tellurium, try that one. The noble gas before it is krypton. It's in the 5th row, so 5s2. 4d10 because the D is full and the D block is going to be one number less than the S. And then it's the 4th one in the 5th row of the P block, so 5p4.